Dear students, Assalamu alaikum. Today we are starting the last part of our age at weaving, the third module. Hope you are fine and okay. I pray for your health and safety. So we are starting today's lecture. So let's start. So today we will be studying first of all the types of subnozzles. In today's lecture, we will see what different types of subnozzles are and how they are different from one another, and what are their preferences, how different manufacturers suggest to use their kind of subnozzles. Then we see in second number different settings of subnozzles, how their settings can be done, and what effect they brings to the insertion of weft. In the third part of our today's lecture, we will see how the air is distributed in the machine, how it reaches to the sub-nozzle or any other nozzle, and how the pressure can be calibrated to see if the pressure is enough or not, or how the cleaning or the alignment of different part is concerned. Then we will see what is the innovation and research done in sub-nozzles in the literature by the manufacturer and in the research. At the fifth part, I will let you know how the pressure distribution is on the machine, what are different type of pressure distribution are, and how it reaches to the different component of the machine. At the last, we will see what are different innovations presently available for different age weaving machines. So let's start it. So today's topic is the technology of air weaving. So let's talk about our today's topic. Dear students, if we go about the literature and find out what different type of subnozzles are, there are a number of kind of nozzles possibilities found in literature. The nozzles can be definitely the nozzle have a taper side which let the pressure blow into the channel of the reed. You can find various type of possibilities for sub nozzles. For example, there are circular type of single hole with circular shape. We can have many pores in circular shape. They can be 16, 12, 13, or 19. Many possibilities are there with various manufacturers. Even within the one manufacturer, there are very various possibilities possible. Uh, a rectangular shape may be possible. I have not seen available commercially, but maybe in the research. Elliptical is another option. Two holes of circular shape may be there, and square form of square grid of circular nose holes or different shapes, maybe star holes. In practice, I have seen one hole circular hole, or its shape may be elliptical, but generally the multi-hole nozzles are of various distribution are possible commercially. So these are the different type of subnozzles from the research literature. So in the next slide, I will let you know what commercially is available. So if we continue with our types of nozzles, we can find basically two types of nozzles. One is single hole nozzles and one are multi-hole nozzles. Various manufacturers support their manufacturing line, their manufacturing technique. For example, the manufacturer of multi-hole sub-nozzles support their technology, and the one manufacturer or other manufacturer that are producing single hole nozzle for their air jet weaving machines, they support their point of view. Uh, Technically, if we see that the multi-hole nozzles provide a consistent distribution of the air, uh, while we can see that if we use only a circular or a round shape single hole sub-nozzle, it can have variations in different regions where the pressure is released. Uh, no doubt, the multi-hole nozzles manufacturer claims that their pressure is optimized. Their nozzle use optimized pressure, optimized air release, while generally the single hole nozzle are advocating their nozzle that they can work at low pressures. How this is possible that they prevent this distribution is the technique mentioned over here in figure D. We can see that the edges of the exhaust are tapered inside. They are focusing on converging the air on one point, that is to prevent this distribution. Toda is one example that is using this type of air sub-nozzles, relay nozzles, and they are claiming that our nozzles can work on low pressure, and they can direct the weft to keep in the channel. So this is a short review of single hole and multi-hole nozzles available in the market. So next, see, there are two more variation possible. They are called S-type and C-type relay nozzles. C-type or relay nozzles are advocated that if you are using filament, warp, warp yarns of filament, multi-filaments, there is a chance that this protruded end of the S-type nozzle may cause splitting of the filament yarns, and they may cause a bad effect or a bad appearance of the yarn. So the C-type nozzles may be used in spite of S-type. No doubt this protruded end also helps to focus the air in the channel that may affect because of these. So, but the yarn effect of the damage of yarn can be prevented using the C type of nozzles. So now we can over here I am showing you how these sub nozzles are placed on the machine. If we see that these sub nozzles are placed on the sleigh of the machine, this sleigh moves along with the reed for the beat up, and the nozzle sub nozzles are placed exactly in front of the reed, and the air is supplied to these sub nozzles from here. You can see the blue pipes, and these blue pipes are attached on the other side with a valve, electromagnetic valve. This valve release the pressure, and the pressure is engaged into the sub nozzle, and the weft is blown in forward direction. By itself, you can see over here the side view. Here is the profile reed, and in front of here are the sub nozzles. And this whole assembly is placed on a sleigh. This sleigh pushes the reed in forward direction or backward direction. And this is our front rest, cloth sport. And cloth sport, exactly on cloth sport, the beater will be done. So there are two concepts right now in the industry. First is placing these valves on machine frame exactly on the air tanks from where the pressurized air is accumulated, and this pressurized air is released by these valves to the sub nozzles. But there is a new concept. This According to this concept, the sub nozzles are engaged to the valves. These valves are placed on the sleigh so that they can move along with the reed, and they can prevent the flexing, the breaking of, because of which the pipes breaks or air clog, That is why the air is consumed in high quantity, or it is wasted, or maybe the high speed is not possible with the at high rate weft insertion. So all these can be prevented by placing the valves on the sleigh and preventing the flexing and length of these pipes. Shortening the length of these pipes, a release of pressure is quickly possible. So there are two concepts I'm showing to you over here in this slide. One is the valves on the frame of the machine that are quite away from the nozzles, and one that are very close. If we try to talk about the sub-nozzle adjustment, there are actually two type of adjustment we need to confirm on the machine. If we see over here in this figure, we see over here is one is this horizontal distance of the sub-nozzle, relay nozzle from the lead, and other distance is this vertical distance from the top edge of the U-shaped reed. We want to fix our nozzle in an optimum position so that this pressure this sub nozzle would be as close to the channel as possible, so that it can release the pressure in the channel at a very efficient way. So with the small amount of pressure release, it can exert more pressure on the weft and push it forward direction. uh, but definitely we do not want to raise our subnozzles enough so that it can come in interact with the inserted weft when the lead come for the forward direction for the beat up. So to prevent this, we have to look forward uh, how much uh, how much forward direction we extend our subnozzle. It must not come in the way of the weft, otherwise it will pushes the weft and cause the making of the nozzle marks. That would be a fault of the fabric. Of course, our major requirement is to keep the weft as in the center possible, as much as possible in the center. Uh, One more thing to mention over here is one of the manufacturer showed in their manual, showed in their advertisement that they have produced the two possible placement of their sub nozzles that brings the sub nozzle very close to the reed's lower edge, so that it can release the air into the channel very in a very better way, so that they can help to reduce the consumption of the air pressure. So in this slide, I try to mention that the subnozzles adjustment is we want to have our subnozzle as much close as possible to the channel to have a very good force applied by the pressure release of the pressure, so that the with the minimum pressure maximum force be exerted on the weft. Here another perspective of this same setting is shown. We can in this adjustment block we can place our sub nozzle. The sub nozzle can be placed by it can be turned inside this block. This turning cause the adjustment of the direction of the release of pressure, and also by rotating we have a threaded nozzle, or we have threads on here on the nozzle, and when we turn it clockwise or anti-clockwise, its position vertical position can be also be adjusted. And as much as we adjust it to the close to the reed, better would be the release of pressure. For example, here are the two settings shown that are not good. Here the weft is too low and here the weft is too far away. This is the optimum setting, the setting of this release of the angle release as well as this its height, so that the weft should be within the channel at the center of the channel. Again over here the same setting is shown like in the previous slide. Here the manual of a piccolo weaving machine is shown. It is telling that if we turn the release nozzles the nozzle hole release holes very close to the reed towards to the reed, the pressure will increase. That will, but in the contrary, if we turn this in a way that the release of pressure is away from the channel, and it will cause less pressure be exerted on the weft in the channel. Over here again the same thing. Here the twist is mentioned. Here the length of the protruding edge of the nozzle is concerned. uh, if we keep it optimum position, we can increase the pressure. Otherwise it will not help to pressurize our weft in beyond such point. Here again it is telling that the thread is one rotation is equal to 1 millimeter. After one rotation, the it would be extended by 1 millimeter. So it can be adjusted as per our requirement, and optimum position can be used for better results. On this slide, I want to mention a measuring tool. Uh, Generally, this is alignment and pressure gauge. It can be fixed within the channel of a profile reed. And here is a very sensitive nozzle over here. When the pressure is released, the air enter into this nozzle and can be measured. Pressure can be measured over here. So for each nozzle, if we want to adjust the pressure release amount from the nozzle, we have to measure for the each sub nozzle. Otherwise, this can also be used for the performance of the profile read. If it is not clean or alignment problem of the dents, we can measure if the read is performing well for the air pressure. So calibration of nozzle as well as the read can be done using this apparatus of pressure measurement. In this slide, I want to mention that there is a very prominent effect of the air pressure applied to the weft in the channel. The distance between the sub nozzle is very important. If we increase the distance between them, we can use less number of nozzles and less release of pressure. Overall, less air will be consumed to insert the weft. If we decrease the distance between the nozzles, it will require more number of nozzles to be used for the same length in this case, but we will have more control over the weft, and we can assure the quality of weft inserted. Uh, in other words, here the yarn path may not be straight, it can come out or cause the problems. Here the yarn will be remain stretched, and there will be less chances of uh, creating a problem. I'm showing you a video that is illustrating how the distance between the nozzle can be helping or disturbing. So let's see the video over here. You can see over here we have 74 millimeter difference between the sub nozzles, and here the simulation is showing the when the distance will be 60 millimeter. You can see that there is a difference. The yarn is more straighter in the 60 millimeter case as compared to 74 millimeter case. Here both cases are compared. Over here you can see the yarn is more straight, and here there are bends because of needles are a little far away. So here in this slide I try to explain the distance do matter. We generally decide this distance on the basis of yarn weight. If we are using lightweight yarn, we can use less number of nozzle, that is more distance. And if we require to insert a heavy yarn, we need to exert more force, and we need to have needle more close to each other. That is why we would have need a more number of nozzles. Different manufacturer gave different tools to adjust fix this nozzle. Over here we can see that this is a special tool provided by Piconol to adjust the distance between the nozzle. We can use it two-way for the small distance and for the distance that required to be that is more distance over here or small distance over here. We can use both way this tool. Here in this slide, I want to mention that here one research is conducted in a literature. In this research, some manufacturer room are shown, and in this machine, they was using a 1.4 millimeter hole, single hole sub nozzle. The researcher showed that they decreased this to one millimeter. Here it is shown over here, and because of this, what happened that their pressure consumption reduced from 63 to 50, and overall they saved this much meter cube per hour from one nozzle, and they computed this for 75 machines for average 35 nozzles, sub nozzles on the same on a one machine, and they find out that annually they can save some 76,866 euros per year on these 75 machines using average 35 nozzles. So I want to mention on this slide that this is very important that we use our sub nozzles pressure very sensibly. Very large amount release for by longer amount release, assure that weft is inserted, but it is overuse of the air. Air is very expensive resource for us. When we are using it, is causing energy, and it diminish in the air if we use it excessively. So we must assure that how we can, whenever somebody is using air jet weaving, he must assure that how optimum use of air can be used so that the cost of production uh, must be controlled in such a way that it is not costly and it is efficient use of air, so that cost does not go very high. In this slide, here is a research here's a research done by Toyota manufacturers. Toyota manufacturer of air jet filling machine. They produce this jet e-read concept. According to this concept, they say that they are changing this U-shape reed. This U-shape reed, they change this its direction, its shape and profile like this. That is, it is more perpendicular or on one corner, and also you can see that this distance that is this edge is more prominent over here. This edge has been reduced in inward direction. You can see the currents they are supposing to produce over here does not push the weft to the exact wall of the reed. But over here they are suggesting that reducing this edge towards the inside and making the profile like this cause the uh, valve to be placed exactly against the walls, and they are suggesting that the because of this reduction in the edge inside, they can also replace the sub nozzle over here or sub nozzle on a little more height that brings it to the more close to the reed, and they are claiming that 20% less air would be required using this technology. So I showed over here you two research. One is from the research literature, scientific literature, and one from the manufacturer. Here, similarly, there are quite much research available that are innovating day by day and producing efficient ways to insert the weft using airjet. So you can go and find for yourself some of the research I will also mention in today's lecture. Dear students, in this slide I want to mention that how the air distribution is done in different machines. Actually, all manufacturers distribute their air within the machine in different ways. Here is a general distribution plan. You can see over here the air pressure is being received from the source, that is generally the compressor, and then this air is distributed in the machine from different filters or some measuring device, how much air is being consumed, some meter something, and you can see these lines over here distributing this air to the tanks, different tanks in the machine that accumulate this pressurized air. But you can see over here different uh, regulators are over here, this one, this one, this one, and this one. Four regulators over here. These four regulators are generally available at the front of the machine, from which you can see you can regulate, you can increase this pressure, release or decrease this pressure, so that the concerned tank will have pressure as per the adjustment, and that pressure will be released from the concerned nozzles, and that's how we can control the pressure amount of pressure from these regulators. So generally the pair of main nozzle will have separate tank, the sub nozzle would have a separate tank, and nozzles at the end of the weft insertion would have a separate tank. So this is the general distribution of air. Here is one example that is I think so by Toyota. They use two type of air tanks. One is high pressure air tank, one is low pressure air tank, and machine can switch between, for the sub nozzle can switch between low pressure or high pressure release of air for the sub nozzles. They do have separate tanks for their main nozzles. So here I want to mention, try to let you understand the distribution of air within the machine. Next we will see how this air distribution is controlled. Dear students, on this slide I want to mention that how the pressure adjustment can be done on the machine. Actually there are two methods. There are two methods. One is the conventional method that use these regulators. These regulators are available with the connection. This coupling connection can be, we can adjust this pressure measuring meter device parameter. There it can connect over here and display how much, this can display how much pressure is activated within this with this regulator. Of course these regulator are mentioning different tanks on the available on the machine, and some few maybe for the main nozzles, and some may be available for the sub nozzles. And we can adjust the pressure over here. The amount of pressure can be displayed on this meter. And afterwards, once we have adjusted the amount, we can go on the machine panel and adjust the release time of different nozzles, timing of release. We can extend these bars in this direction or in this direction, or contract them, and that will decide how long the different nozzles will release the pressure. We want to assure that our valve would read constantly on time before the shed closure. And that's how the combination of these regulators, adjustment of the pressure, and then adjustment of the timing, we can adjust the pressure of the machine. These regulators are available on the front of the machine. Here is one example. If it runs, like over here, you can see this is Sodocoma machine. On the front, you can see there are different regulators. Like over here, it is a picanol. Like over here, it is the picanol machine. This picanol machine, and you saw over here was the uh, Sodocoma machine on the front. You can see these regulators, and from here we can manually adjust the pressure of different tanks, and conversely the different nozzles pressure. But the other way is today's new technology. Electromagnetic regulators. The electromagnetic regulators are attached with machine control. Electronically, we can control them from the panel. For example, over here is mentioned picanol machines panel over here. Here you can adjust the pressure from the panel, and the pressure is adjusted electronically on the machine. And in this way we can control more automation. And in this in the new machines, this automatic control are be available. It also helps to perform different functions like automatic adjustment of the pressure, as different variations are made on the machine. So two type of regulator are possible. One are manual regulator. This is old technology. And the one are the electronic regulators that can be controlled from the machine panel. So this is I want to tell you all about the different type of how the air pressure can be adjusted on the machine, and then it is how it is run on the machine. With this, dear student, I conclude my first part of this module 3. Uh, Afterward, I want to mention what are different innovations provided by different manufacturer. So I will resume this in next lecture.